Hello, Algebros. We're going to continue with section 8.5, today's lesson, exponential functions. We have been looking at some linear functions, and the linear functions can be used to model different situations in real life, but exponential functions can also help us. They're very powerful tools that are capable of representing many scientific and financial phenomena. In a linear function, the change in the dependent variable is constant during each unit of time. In an exponential function, though, the dependent variable increases by the same factor during each unit of time. And these relationships can be represented here with x or y equals 2x, and then y equals x squared. If we look at examples like this, the base is a constant, but the exponent is the independent variable. Okay, we'll explain that a little bit more here. Now, the first problem here, y equals 2x, that gives us a straight line. Okay, well, that's called a linear function. For the second one, y equals x squared, remember when we have x squared, we saw that it gives us a parabola, a curve like that. And when we take some examples here, 2 cubed, okay, that gives us 8, right? Now, 2 to the negative 4th power, we flip the 2 to the 4th power, and we get 1 over 16. Okay, so that's our reciprocal. The negative power gives us the reciprocal. And then if we have 3 times 2 to the 0 power, what happens to the 2 to the 0 power? It becomes a 1. And then we have 3 times 1, and then that gives us 3. An exponential function is a function of the form f of x equals a times b to the x power, where b is greater than 0 and b is not equal to 1. All right, let's take a look at a first example here. Okay, so this is the example on page 350 in your textbook. It says create a table of ordered pairs and graph each function. So we have this equation y equals 2 to the x power. So if you create a table, just like the one that's in your book, okay, and then we're going to, let's say our x is negative 3. So you're going to have 2 to the negative 3rd power. That gives us 1 over 8. Because remember, any number raised to a negative power is the reciprocal. It means to find the reciprocal. Okay? If our number was negative 2, 2 to the negative 2 power, then we take that 2, find the reciprocal. That's going to be 1 over 2 to the 2 power, or 1 over 2 squared. And then that gives us 1/4. If our x is negative 1, we take the reciprocal. Okay, 1 to the negative 1st power is the reciprocal of 2. That means 1/2, and there's our y. Y equals 1/2. If we had 0, any number raised to the 0 power, remember, gives us 1. Now, for a 1, 2 to the 1st power is 2. 2 squared is going to give us 4. And then 2 to the 3rd power gives us 8. Now, let's take another example, okay? Let's create a table of ordered pairs if our base was 1/2. Okay, so we're going to plug in the same numbers for x. If 1/2 to the negative 3rd power, remember that means to find the reciprocal. You're going to flip your base right here, flip it upside down. 1/2, the reciprocal of that is 2. So 2 cubed is going to be 8. 2 to the negative 2 power means I'm going to take, or 1/2, I'm going to find the reciprocal, flip it, and then square it. Okay, so 2 squared now is going to be 4. Then 2 to the negative 1 power, I just basically, negative 1 power means find the reciprocal. So 1/2 becomes 2. 1/2 to the 0 power, remember any number raised to the 0 power is going to give us 1. And so we have 1. If it's 1 for x, then 1/2 raised to the first power is 1/2. Now, if we have 1/2 squared, then it's going to stay a fraction, and that'll be 1 to the 4th power, or 1/4. And then 1/2 cubed is going to give us 1 to the 8th power. Now, if we graph each of these equations, okay, here is our graph for y equals x, or 2x to the x power, is this graph right here. Y equals 1/2 to the x power is going to give us this graph. Now, an asymptote, okay, you would pronounce this an asymptote. You don't pronounce the P there. An asymptote is a line that a graph approaches but never intersects. So, in example 1, the two graphs that we saw earlier, both functions, the domain is the set of real numbers, and the range is a set of positive real numbers. All right, now in example 2, okay, we have, this is going to be on page 351. In this example, it says graph y equals 3 times 2 to the x power on the same coordinate as y equals 2 to the x power. You have this, y equals a times 2 to the x power is different, okay, from y equals 2 to the x power because of the every value of x, the corresponding value of y will be a times, this one has a times it. When you're multiplying this by a, okay, that's going to change the graph. It's going to make it a little different, and we'll see how here, okay. The y-intercept will be 0a. Okay, so where this graph crosses the y-axis is going to be at 0, x is going to be 0, but the y is going to be at a, whatever a is going to be right there. Okay, now, let's take a look at this, where y is p to the x power. Okay, our problem here, this is example 3 on page 351. Photocopiers and graphic programs allow the user to enlarge or reduce an image using a percentage of the original, p. That's the percentage of the original. The equation y equals p to the x power can be used to find the effect of successive enlargements or reductions. What percent of the original is the image produced by each of the following? You round to the nearest tenth of a percent. So let's say that we have 3 consecutive reductions of 75%. Our P is 75% or 0.75. So then if we plug that into our equation, y equals 0.75 to the x power. Now, it says 3 consecutive reductions, okay? That means the x is going to be 3, okay? You're making the picture smaller and smaller and smaller 3 times. 3 times in a row, okay? And so you got to find out, what is that 75%? Okay, so 0.75, that's the percentage, and reduced at 3 times the x. That means 0.75 raised to the third power, and it gives us approximately 0.422. So about 42.2% of the original is how this picture is going to come out. Okay, and how did we get 42.2%? It's from here. You move your decimal over 2 places, and that gives us 42.2%. Now, let's say we want 4 consecutive enlargements of 150%. You're going to take this photo or this document and enlarge it to 150%. Okay, so your percentage is 1.5, and our formula is going to be y equals 1.5 to the x power. So we want 4 consecutive enlargements, so that's what our x is going to be, 4. 1.4 to the 4th power gives us approximately 5.063, and that means we're going to get about 506.3% of the original. That's a very large enlargement of our document. Now, let's switch over to some banking accounts here, okay?